Okay, so to recap, we're going to go over how it would be possible that if you're only given 75 ohm resistors, how you can make an equivalent resistance of 25 ohms, 100, and 150. And this has to go back to the equation, series, and parallel. So to start with 25, how is it possible to break 75 down to only get 25? So what you'd have to end up doing is having something like this. And what happens here is that we get 1 over 75. So 1 over 75 plus 1 over 75 equal to 1 over the resistance value. And when you do the math for that, what you end up getting is 25. So that's how you would do the math needed to break 75 down to 25. Now next, 100. Okay, to make this easier on both of us, I'm just going to use what we had here and just write it out from there. So we'll use and then on there. So what we see here is after doing the math for these in parallel, we get 25. So when you get 25 plus a 75, you end up with 100 ohms. And that's how you would break it down into, or that's how you would add 75 to get 100. Now for the final one, 150, this one's pretty easy. You just add 75, 75, and you get 150. So, and that's how you would use all this in the parts. So now I'm going to go back over Kirchhoff's law, and I'm going to give you a mathematical representation to see how this would all work and how we would do this mathematically. Okay, and now going back to the loops, just to save space, I haven't included the loop or the equation, but I'll explain it as we go. We're using the same equations that we calculated from the first example from the loops. And I've given us a couple values here, so I don't know if you can see them, but V is equal to 12, R1 is equal to 10, R2 is equal to 20, and R3 is equal to 30. So the first equation that we got, or that we figured out, was the velocity, or like the V value, not the velocity, but V minus I1 times the resistance of 1 minus R2 times the current of 2 minus I1 again, and the resistance of 1 is equal to 0. See that? And from this step, we can simplify because we have two I values, or two I1 values. So we end up getting here 12 minus 20 I1 minus 20 I2 is equal to 0. Okay. And then what we do next is we plug it into the next one. So the next one we end up getting minus 30, which is the resistance for 3, I3 plus 20, which is the resistance for 2, times current of 2 is equal to 0. So what we're going to end up doing here is that we are going to add 30 to the other side. And we're going to isolate one of these values so that we can plug it back in there. So if we do that, we would end up with 20 is equal to I3 over times 30. So divide that back. 2, 30 is equal to I over 3. And then we have to plug it in. I'm sorry, I actually made a mistake on the last one because we needed to be in I2 to plug it back into the other equation. So I2 equals 3 over 2 I3. So then we plug it back into our first equation. So it would be 12 minus I1 10. I'm sorry. 20 minus 20 over, we could just keep it 30 over I3 to the 24. As you see there. And what ends up happening here and then we go to the equation I1 equals I2 plus I3. So where we would do this is perfectly going to do the top equation. So it would be 12 minus 20 I2 plus I3 minus 20 I2 to 0. So when you get this all worked out, you get 12 minus 40 I to the second minus 20 I to the third is equal to 0. So you end up getting anything by itself, you get I to the third is equal to 12 minus 40 over 20. And from here, we plug that back into the bottom equation. So what we end up with is minus 30 equivalent to 12 minus, sorry, I forgot about the second I, minus 40 I to the second over 20 or plus 20 I to the second put a 0. So after a fair bit of math, what we end up here is it would be 80 I to the second is equal to 18. And that has to do with the fact that like, you can split that up into 3 over 5, 3 over 5 times 30, 18. And then because it's the negative sign, when you subtract it, it cancels out into 18. So when you do 18 divided by 80 to find the second I value, what you end up with I to the second, I'm gonna write this actually up here. So the second I value is equal to 0.225. That's the answer for the second current. So then what we can do from there is go back to the first equation. One second, let me erase my board. Okay, and now we go back to the first equation. So it would be 12 minus 20I minus the 0.225, which is what we got as I2 times 20. What we end up getting here is 7.5 after you do the multiplication here, minus 20I equal to 0. So you get negative 7.5 divided by negative 20 is equal to 0.375 amps. Our currents are measured in amps. So then what we do from there is we simply plug it back into the I1 is equal to I2 plus I3. What we end up getting is 0.375 subtracted by 0.225 is equal to 0.15 amps. So after all that math, what we can finally get the answers for all of the current values is I1 is equal to 0.375. The second current is equal to 0.225, and the third current is equal to 0.15. And that is how you would mathematically solve one of the Kirchhoff laws equations, which is the sigma of delta V is equal to 0. And with the other equation of V equals I times R, all of them are just the V values. So we just solved for the Kirchhoff law with other parts of resistance and capacitance worked in there, all about the DC currents. And thank you for listening to this project, and thank you for the time and consideration.